program. I'm very happy to be here today. So I'm going to talk to you about a topic that a lot of people might not like, GDPR. And basically I'm going to describe the work we did in JP Morgan Chase with regard to supporting GDPR compliance through our enterprise data governance project by efficiently governing data lineage and provenance metadata. So, to give you some intros, basically I currently joined the Zerva as a cognition analyst representation lead. My current focus is going to be on planning the data governance strategy for life sciences and internet. And before, I've been working in JP Morgan Chase on trying to create a unified enterprise data governance platform program where we will be able to unify metadata from different sources into a common place and be able to basically cope with different requirements we have, like regulatory requirements such as GDPR. So, if you start giving some definitions, what data governance is, how can we define data governance? So data governance is a set of processes that allows us and ensures the data assets are efficiently managed, gaining control and have a better understanding of your data. It basically allows us to gain traceability with regards to the data an organization has, and also to be able to showcase accountability with regards to issues such as data quality, retention, data lineage. It also is an evolutionary process, so maybe one part of an organization starts building some processes around data governance, and then this evolves as long as new requirements about data come in, and new requirements about data integration come in as well. And the types of processes encompasses is basically about collection of data and metadata, analysis and validation of rules and metadata, and also about linking data and metadata. Now, data lineage is basically referring to capturing the sequence of data flows involving a data element. So basically we can understand how a data is coming from a source, from its origin, and how it evolves by moving through different flow activities. While the provenance is more about looking at the recording of the processing activities, data are involved, so therefore we are looking about real-time provenance and provenance logging information. And GDPR, as we all know, is the General Data Protection Regulation. So let's start by giving an introduction to how the enterprise data governance platform looks like. So basically, what we tried to do with the enterprise data governance platform was to try to support efficiently the metadata management and the governance itself within the corporate technology. So the main mission of the IA team was to integrate city metadata from various sources in a common place and in a common representation. So we used RDF for that. And the second mission was basically to be able to consolidate lineage and provenance information together with other metadata such as glossaries and taxonomies and external reference data sets, etc. So what we were able to do is, first of all, collect information from different formats and from different distributed sources, be able to translate those data and metadata in a common format. So we standardize based on specific schemas expressed in OWL. We were also able to use a layer of SACL on top of that to represent the data and metadata in the way we wanted based on the different requirements and the customer needs. And we were also using spin rules in order to do the transformation from, let's say, the raw initial source to the actual unified representation schema. And in this way, we are able also to connect. And on top of the connection of this linked data, we're able to query across a unified structured information, and also link and query across with other internal and external reference data sets such as taxonomies, the JP Morgan glossary, and possibly other external standards such as FIBO, for example. So the enterprise data governance ecosystem more or less is composed of the sources. So in this case, the sources were the enterprise metadata, such as logical and physical data models, requirement reports, glossaries, taxonomies, code lists, external standards such as FIBO. And the main processes and tools and services involved were ingestion pipeline for the enterprise metadata, building models, having provenance loggers in place, being able to track the movement, basically the data lineage, and also being able to, let's say, give feedback about the actual models and the metadata by having reviews with domain experts such as business domain experts. And in this way, we were able to create this unified data and metadata hub that we called EDG, and be able to use that for basically races, so looking into entitlements and ownership with regards to data and metadata. We were able to create APIs and extract information out of that for different use cases. We were able to do discovery, but also, most important do a lot of regulatory reporting. So the business cases we had was basically capturing the metadata, capturing the governance requirements for the complete portfolio of corporate technology applications, supporting the development lifecycle with regards to regulatory requirements such as GDPR, demonstrating data lineage, demonstrating provenance, looking in the traceability, so how the data are linked across different applications, for example. We were also caring about the contextual alignment with firm-wide standards, so like the standard glossary we had for JP Morgan organization, and also alignment with other taxonomies and glossaries. We are also being able to do analysis and validation over the data quality and the data accuracy, and also exhibit accountability with regards to entitlements by using provenance. For example, by having all this in place, then we were also able to do crosswalks between the models and the ecosystems and answer questions such as which application contains personal information data affected by GDPR, which is a regulatory reporting requirement. Or we can take a look on the retention policy requirements and ask, Saudi Arabia has changed its retention policy, what applications are affected based on the personal data they contain. Or we can look into the ownership entitlements requirement where we ask, what are the owners of particular data requirements documentation? And this is how the metadata governance model is actually looking within Edge platform. So we basically have, I'm not sure I can use that. So we basically have physical representation and physical data models. We have logical data models that correspond to the logical data model artifacts. We have requirements that are associated to the logical data model artifacts. And then we have business terms that are basically describing in a common way as part of a data dictionary the logical data model artifacts. We also have application metadata in place. So this is more about the actual application information, deployment information within organization. So we're also interested in this way to link the different artifacts to the applications those are deployed and to the applications those are transferred or processed with. Then another aspect, so this is basically the data lineage aspect. Another aspect we were looking into was the data traceability. So the data traceability is about looking again between the metadata links, but when this happens in different systems or different applications. And then we also have the data provenance aspect. And data provenance aspect is about looking in the processing activities and the recording of the processing activities. And in this way, we are allowed to track things such as ownership of specific data within an application, entitlements and access controls, and also look into other things that are also important for the GDPR, such as the business capabilities and the business purposes the PI data are used for, and also recording the processing activities, which are important for the GDPR because we need evidencing of the actual processing activities. So if we take a look on how the data lineage is visualized, so we have used top quadrant solution, and we have built basically our custom solution on top to represent our data lineage. So basically, for a data asset such as workforce, that is basically connected to an application for human resources, we will have a logical data model artifact, and this would be related to a physical data model artifact, which is basically realized by a database. In this case, it's a NoSQL database, and has an upstream dependency to an actual application. So this is about the technical metadata information we hold for this artifact. And as we can see, there are more information on that, such as the business capabilities that are involved, and also about the organization. So we can see the ownership with regards to the application here as well. Also, if we go back to the logical data model, we can look into a more fine granular level with regards to that. So a logical data model will have a set of entities corresponding to that. So here we see an example called worker, and then we can go to an even more fine granular level and see logical attributes with regards to that. So basically, we can see all the metadata information at the most fine granular level. And in this level, we can see information such as logical data types. We can see whether that is a primary key or a foreign key, the nullability information, etc. And these are all things that get reported to regulators with regards to data quality, for example. So as we can see, the last section of that is traceability. So what we can link to more from this level is we can link to the data dictionary of the whole organization. So we actually, sorry, that's this slide. So we actually get an understanding of the definition of this particular artifact with regards to a business term that is provided for the whole organization, and we can also see the associated business rules with regards to that. And we can also map to other metadata, such as the requirements related to this artifact, so we can understand for what business requirements we actually need this artifact and where this is processed. Now, if we go back to the physical data model, we again have a more fine granular level with regards to this metadata. So we will get physical table information and physical column information. And those are all linked up to the logical artifacts we saw before. So the data lineage diagram would look like that. So basically, the physical data model artifacts are linking to the logical data model artifacts. We have mappings to the technical information with regards to these artifacts, and we also have mappings to the data requirements and the glossary dictionary information. So basically, this whole picture gives us the lineage, and it basically shows how we govern the lineage with regards to all this metadata for an application within corporate technology. Now, let's take a step back and think how this can help us with GDPR. So GDPR is a new set of European guidelines that basically gives instructions of how personal data should be handled by organizations. And according to GDPR, things should be processed faithfully, fairly, and lawfully, and must be retained accurate and should be kept up to date. We really care about the retention periods here, and also we also care about the security. And there are two main terms in GDPR that we care about. This is the controller and the processor. And basically, those are the parties that are involved in the processing of the PI data. Now, the controller is basically the party that decides what data is extracted, the purposes those are used, who is involved in the processing. And what the controllers should be able to do is to demonstrate compliance. So basically, the controller should provide accountability metrics with regards to how the PI data that are incorporated on the different processes are handled, and should be able to also report on the purposes of processing and the categories of PI data it controls. Now, the processor is actually the party responsible for doing the actual processing work on behalf of the controller. And the processor should maintain records of the categories of processing activities of PI and also the means in which this is processed. And it should also be able to report on data transfers, for example, to a third-party country or in another organization. So the challenge here with regards to the requirements for the GDPR is that organizations need to really record personal data processing activities as an evidence of demonstrating their compliance. And they actually need to do that in every point where processing activities of PI data take place, and that's quite hard. And the solution we try to give by using the governance aspects we had in the project was to basically focus on the data lineage, because data lineage enables the understanding of your data flow activities, and therefore it allows us to identify it allows us to identify like the legal justification for each type of activities involved on the processing of its data artifact. Now, the other thing that data lineage gives us is it gives us a visual representation of the actual flow of and movement of the data from the source to its destination. And basically, this helps us to track down whether a specific artifact complies in the different movements it has, like to the overall compliance process. On top of that, GDPR requires, as I said, on the processor aspect, the ability. So, sorry. It requires on the processor aspect to be able to. Sorry, I really lost my lines. So it requires to provide evidence records of the actual processing. And basically this implies data provenance. And data provenance, as I mentioned already, refers to the actual recording activity. So we actually need to care both about the provenance information, but also the lineage information. And with provenance, basically what we can do is we can verify through recording the processing and the steps whether a specific result is complying to requirement. And in this case, the requirements we have are GDPR regulatory requirements. So if I give a use case now about how we use the data lineage I described before in order to showcase compliance with regards to one of the GDPR data requirements. What we can see here in GDPR Article 30, there is a requirement that asks to provide time limits for erasure of the different categories of data required per record retention policy. So what this means and how this is translated in a kind of requirement internally in the organization is that we need to return the applications that are in scope of the GDPR for corporate technology, and also to return, as a result, and understand what are the record class codes, where the record class codes are basically used to determine how long to keep its record per jurisdiction. And to do that based on the different record retention policies you will have for different countries. And the last thing we need to do is we need notifications to the application owners that if something is changing in the record retention, let's say policy, we need to keep them updated. Their applications are still in compliance with GDPR. So what we did is we tried to link the different metadata we had into the enterprise data governance platform in order to solve this problem. So for example, we would link the technical metadata coming from a system called SEAL with retention manager information metadata that were containing the information about record retention codes and the associated record retention policies. And in this way, by linking this metadata, then we were able to infer on the business application level whether the specific application contains PI data, so whether it basically is in scope of the GDPR because it actually contains data for personal information, whether also to understand what is the record retention class, and what are the corresponding record retention policies per country with regards to this application. And also we were able to infer information with regards to what processes, activities are incorporated in the handling of this PI data. So we would be looking in the provenance information. And at the end, by creating business rule, by using SACL, we were able to have an automated update of whether this application is still in compliance with GDPR or not. And if we deep dive a little bit more on the actual record retention class information, we can see the metadata about record retention code. It looks like that. And it also has links to specific policies. Here we can see a link to data retention policy for Austria. And this is the actual metadata instance for record retention policy for Austria, where we can see the retention period and whether this is still in compliance with regards to GDPR requirements. And here I have a diagrammatic version, so a visualization of how a record retention class links to a retention policy. And here is the metadata with regards to the actual retention policy. Now, having all this lineage information governed all together, what it allows us very easily to create a report, but by even running a simple query, and this query can return us information about what our applications are in scope, belonging to a specific line of business, what are the record retention class codes, and what is the associated policy, as long as with whether this is GDPR compliant. I wanted to add a little bit of technical information on top of that. So with regards to being able to infer this information, we use these spin rules in order to represent the linkage of the metadata between the record retention class codes and the record retention policies. So these are examples of spin rules. And with regards to how we want to represent for a specific entity, such as the record retention class code, specific property information, such as the link to policy, we use it SACL property constraints. So that was for the interface implementation. Not sure I have time. I think I should not get into more details.
Yeah, we're right into question time now, right at the end of question time even. But it's fine. It's only we've got half an hour coffee break coming up next.
Okay.
So,
thank you. I can.
Yeah, we've definitely got time for questions. So always time for questions.
Thank you for the very interesting talk. You showed in one of your early slides all the artifacts that play a role in creating a meaningful lineage or around the data governance platform. Assuming that, as the majority of the companies, Elsevier has also certain artifacts which are not possibly connected outside the governance platform, what I would like to know is how long did it take to load all the logical models, various physical models, reference lists, code lists, and reference data into the top quadrant solution? Mm-hmm. How long it took to do the linkage? And how are you planning to maintain this? I guess the physical models will be changing as you have to change vendors. So how yeah, how are you thinking of moving it forward?
Just to clarify, that solution was with regard to JP Morgan solution artifacts. It's just because I moved to another organization recently. So basically, with regards to the ingestion of different physical data model artifacts, what we did is we built harvesters to ingest from existing vendor solutions that are kind of standard within the organization. So building our own harvesters for that, I would say, took maybe 6 to 8 months to stabilize, but that was not necessarily because of the implementation. Let's say it was not only because there is difficulty in the implementation, the translation necessarily, but it was more about understanding what are the requirements of what we need to translate for a lot, for different line of businesses. So I think it was more an exercise about understanding the requirements and less about the actual implementation. Now, with regards to building models and schemas, I mean, this is like an ongoing process. So for the modeling work, I would say it took us like 2 years with teams that were growing in numbers, so we could, let's say, speed up on the modeling work. And with regards to loading other external vocabularies and taxonomies, this also has to do again with having an automated ingestion pipeline. So I would say that it's easier because when you have a taxonomy, you just digest this as a reference data set, so you don't care about having specific requirements to build a harvester. So for that, I think it was much easier to create this harvesting automated pipeline than for the actual data sets that might slightly be different based on the different requirements. So the overall thing took around 4 years.
Okay, and how?
But it goes for like a very large-scale organization, so.
Understood. And how are you thinking to maintain? So I guess there's a whole governance organization responsible for maintaining this.
I'm sorry?
I assume that there's also a whole governance organization responsible for maintaining this and making sure this is always up to date to meet all the compliance requirements, right?
So, I mean, with regards to understanding whether this stays, like maintains in good quality, etc., we were also building metrics around that to check, have checkpoints with regards to the quality of the data and metadata. But yeah, there is like an information architecture team that keeps evolving that, so that's the idea.
Okay, really big round of applause for Paraskevi. Fantastic presentation.